I have had a huge amount of demand for more algebra and inequality practice, and that's what this video is. This is 15 questions that are harder level, I would say medium and hard, covering both algebra, linear equations, and inequalities. I'm going to be solving them live, so to speak, and at the end I will let you know if I got any of them wrong. But for now, feel free to answer along with me, maybe by pausing the video and seeing what you get first, as I complete these 15 drill questions at the harder level for linear equations and inequalities. Starting with this one. What is the value of xy over z squared when z equals 3x, y equals 4z, and xy doesn't equal 0? Okay, well, let's just sub those in. So we can make everything in terms of x, I believe. The y we can change to a 4z for now, and then we'll convert that to an x in a second. We're just subbing in these two equations here into the fraction on the left. So I've changed the y into a 4z, and the z squared is now going to be 3x squared. And remember here that the 3 as well as the x is going to be squared. A common mistake would be to only square the x and say the answer is 3x squared, but no. Quickly working it out a little bit, the 3x squared in the denominator is 9x squared. And the z, as I promised earlier, we are now going to change into 3x, so that everything is in terms of x. How else can we actually solve this fraction and get an numerical answer unless everything cancels out? So we need everything in terms of x. So instead of writing 4z, it's now going to be 4 times 3x, because z is 3x. Working out that top line, we have 12x squared, and lo and behold, as predicted, the x squareds are going to cancel out and give us 12 over 9, which if we divide by 3 becomes 4 over 3. So the second one is the correct answer. Okay, that was a nice warm-up question. Let's get on to the second one. If any of these are quite hard for you, don't worry too much. I've started at the hard level. Maybe in a future video, I'll do the low and medium drill set. Okay, the link is in the description, by the way, to these questions from Exam Planet with the answers as well and the explanations. You can assume, by the way, that I'm getting these right. If I've gotten any of them wrong, I'll tell you at the end of the video. But for now, we're not going to be checking the answers. We're just going to go straight through question by question. The sum of two integers is 27. So I would write x plus y equals 27. The larger integer, let's say that's x, is 25% greater than the smaller integer. So x, how do we write 25% greater? 1.25. That's how you represent 25% greater. What is the positive difference between the two integers? So the question is interesting. What is the positive difference between the two integers? To find the difference between them, they want us to work out x minus y. Okay, well, much like in the previous question, I'm going to sub it in. So you see how x equals 1.25y. I'm going to place that into the first equation that I created to give us 1.25y plus y equals 27, and 1.25y plus 1y is 2.25y equals 27. Many students would get scared at this point because of the decimal, but let's immediately get rid of the decimal by multiplying by 4, for example. That would give us 9y equals, timesing that by 4, I think I could do that in my head, that's 108. Divided by 9, obviously again you could use a calculator, but I think I can do this in my head. 12, I think, so y is 12. Okay, if y is 12, going back to this first equation at the top, we know x plus y equals 27, so x must be, what is that, 15 to add up to 27. And what is the difference between them? Well, x minus y, the difference between 15 and 12 is 3, so the answer is A. I'd say the key moment in that question was writing down that if x is 25% greater than the other number, then x equals 1.25y. Also getting rid of the decimal at this point here by multiplying both sides of the equation by 4. You could multiply both sides of the equation by 100, And that would work particularly with the calculator. You'd then have to divide by 225. Anyway, next question. And I can see question 5 down below. We're getting on to inequalities. So if you're looking forward to that, that'd be great. Question 3. What is the product of the factors of twice the sum of the roots of the equation? They are really trying to intimidate me and you here with all these words, but we're not intimidated, are we? Let's work from the back. First, let's find the roots of that equation. Do you notice something we can immediately do with this equation? It's really helpful. We could divide everything by 2. So we get x squared minus 2x minus 3 equals 0. Such an easier equation to factorize and solve. Yes, that's right, we're going to factorize it. I've done videos on this, but we need two numbers that multiply to get minus 3 and add to get minus 2. What would that be? Minus 3 and plus 1? Yes. So x minus 3 is the first bracket, and x plus 1 is the second bracket. And we have factorized that quadratic equation, giving us the two solutions, x equals 3 and x equals minus 1. Again, I've done another video on that, so I'm not going to go into details in that method, but either way, those are the two solutions or the two roots. And if the two roots are 3 and minus 1, then the sum of those roots, 3 plus minus 1, is 2, right? If you add 3 plus minus 1, those are the two roots. If we sum them up, 3 plus minus 1 is 2, yes. But then it says twice the sum. So we're working backwards. Twice that sum, well, 2 times 2 is 4. So 4 is twice the sum of the roots of that equation. And now we've got to find the factors of 4. What are the factors of 4? 1, 2, and 4. Those are the 3 positive factors. You can always assume positive, by the way. Those are the 3 positive factors of 4. There are no other numbers that go into 4 perfectly. And finally, they want the product of those factors. Product means multiply, so 1 times 2 times 4 is 8. So the answer is 8. Really, they were just trying to intimidate you with the number of words, product, factor, sum, root, but each of those in turn we can do quite easily. To find the roots, we simplified the equation by dividing by 2, factorized. Once we found the roots, we could find the sum by adding them up. We could then double that, then find the factors of 4, and product just means multiply. Not too bad. Okay, next one. If a is a positive even integer, okay, and ab is a negative even integer, then b must be which of the following? So if a is a positive even integer like 2, and then ab is a negative even integer, well, we know b has to be a negative, because otherwise, why does it turn out to be a negative even integer? So we know b is negative, but we don't necessarily know that it's even or odd, because an even times an even is even. Also, an even times an odd is still even. Anytime even is there as an ingredient, the product will always be even. I've done a video on evens and odds, so do check it out. So we know that b is negative, and we know that b is an integer, but we don't know if it's odd or even. So the answer would be C. We know it's a negative integer, but we don't know that it is a negative even integer. So it's not that. And it's definitely not positive, And it is a negative number, but more specifically, it's a negative integer. So technically, both of these would be true. It's a negative number, and it's a negative integer. Actually, do we know that it's a negative integer? I've got to be careful here. It depends if the question was tick all that apply or not. Could it be like minus 0.5? No, because then it wouldn't be even. Or it could be actually, because A could be the number 4, and B could be like negative 0.5. And then it turns out to be negative 2 when you multiply them. So B doesn't have to be an integer. So it's actually not C, it's just A. We know that B is a negative number, but it doesn't have to be an integer, and it doesn't have to be even or odd. Wow, I almost got caught there. I really almost got caught. But b could be a decimal and the answer would still be negative and even. That was a really interesting one. If that was a tick all that apply question, I would have almost got it wrong, but not quite. I didn't get it wrong. So let's move on to the next one. Finally, some inequalities. If -1 is less than a minus b, which is less than 10, with b being an integer such that b is between -3 and 1 inclusive, what most accurately describes the range of a squared? Okay, well, I'm going to sub in the two extremes. So I'm going to first sub in -3, and then later I'll sub in 1. Subbing in -3, if b is -3, it becomes a take away -3. Don't forget there's two negative signs there because there was a minus there already. And then if b is -3, there's another negative sign there. And the two minuses will become a plus. So that's actually +3, a +3. How do we get rid of that +3 in the middle? We take away 3 from all three parts of the inequality. We take away 3 from the left, from the middle, and from the end, giving us -4 is less than a, which is less than 7. So a is between those two. And now let's do the same, but subbing in 1. Okay, we've subbed in -3, so now let's sub in 1. I'll do it over here. So if b is 1, we get a take away 1 is less than 10. And we can add 1 to all three sides of the inequality to give us 0 is less than a, which is less than 9 here. Oh, sorry, we're adding 1, my bad. Almost made a mistake. It shows you that anyone can make a calculation error. I almost put 9 there, but why did I stop? Because I'm always paranoid about my calculations. I always love to check my calculations and not rush too much. Actually, it was 11 there. Because if we're adding 1 to all sides, 10 plus 1 is 11, not 9. Oops-a-daisy. Anyway, the question is, what most accurately describes the range of a squared? Well, looking at the answers, a squared can't be a negative. So these two answers are out, meaning it's down to these. The smallest thing a could be would be 0. Well, I should say the smallest thing that a squared can be is 0, because a square can't be anything less than 0. So it's down to C or D as the answer choice. And what is the biggest thing that a can be? Using our two solutions, we've got our first solution here. A could be between -4 and 7. And our second solution here, a could be between 0 and 11. Well, at its biggest, a could be just under 11, meaning that a squared would be just under 121. So I would pick answer D here. And notice I got that by subbing in the extremes of -3 and 1. I didn't bother subbing in -2 or 0 or anything like that, just the extremes to get the extreme values for A. So I would pick answer D. Okay, next one. And then there'll be more inequality questions coming up later. Got this first equation and a second equation. What is the sum of x and y? Okay, well, first thing I'd do before I even think about the question is I would multiply both sides of this first equation by 2 to get rid of that horrible decimal. If we do that, the 0.5 becomes 1, which disappears, and the right-hand side becomes -2. So I've got rid of the decimal. X squared minus y squared. Done a video on this, but you should immediately think about the difference of two squares. I know many of you won't think about that and how to factorize it. Check out my video on the most important quant formula you need to know. And I talk about why it's really important to know how to factorize x squared minus y squared. Either way, we know that y minus x equals -2, and we know this. Now, some of you might find that awkward because we've got a y minus x here, but on the right, we've got x minus y, which is not the same thing. I'm going to resolve that by timesing by -1. Essentially, you flip the equation. So y minus x becomes x minus y, and the -2 becomes 2. It's a neat little advanced trick, but think about it. If y is times by -1, it becomes -y, which is here. if minus x is times by minus 1, it becomes positive x, which is here. And if minus 2 is times by minus 1, it becomes 2. So it does work out. Essentially, you're flipping the signs. So if y minus x is minus 2, then x minus y is 2. And if we know x minus y is 2, we can sub that in here, meaning that x plus y times by 2, because we know x minus y is 2, equals 24. Dividing both sides by 2, we have x plus y would equal 12. And that's the question, right? The sum of x plus y, or the sum of x and y, is x plus y, which is 12. So answer D. Obviously, I'm going relatively fast because I want to show you the kind of pace you want to go at for the real test, but feel free to pause, rewatch, rewind, because I'm going at a fairly fast pace. Okay, the next one here. The quotient of x and y is 2. That's a fancy way of saying when x is divided by y, you get 2, or it equals 2. So them saying that the quotient of x and y is 2 is saying that when you do x divided by y, it equals 2. Just a fancier way of saying it. If x is 75% of z, so x equals 0.75 z, could have used fractions there maybe, but which is 3/4 larger than w. So z, which is what the which refers to, z is 3/4 larger than w. How do I write 3/4 larger than w? That's w times 1.75. Or I could have done 7/4 w. But 3/4 is 0.75. So to be 3/4 larger, you times by 1.75. It's a bit like if I said something is 25% larger, as we saw earlier. That's times by 1.25. To be 3/4 or 0.75 larger, that's 1.75. And that's what z equals. Z is 1.75 times w. Okay, what is w in terms of y? Well, it's going to be a series of substitutions, isn't it? We know that z equals 1.75w, so we can sub that in up here. And that gives us x equals, now notice the answers are in fractions, so I'm going to immediately convert everything to fractions. So instead of having 0.75, I'm going to have 3/4. And instead of subbing in z as 1.75, like I said earlier, I'm going to sub it in as 7/4, because 1 is 4/4, and then 3/4 is obviously 3/4. So 4/4 plus 3/4 is 7/4. So there you go, I've subbed it in, all in terms of fractions, giving us, actually I'm not even going to calculate that because I'm now going to sub it in over here. If we get rid of the fraction in our first equation, timesing both sides by y, we have x equals 2y. And if x equals 2y, I can put that in to this equation. So I actually know that 2y equals, let's work that out now, 21 over 16w. Okay, running out of space a bit. And what do they want to know? They want to know w in terms of y. So they want us to isolate the w. I would times both sides by 16. So we have 32y equals 21w. And then divide both sides by 21. So the answer is 32 over 21, y equals w. In the real test, I'd strongly recommend you give yourself more space than I have done. But either way, that would be the correct answer, which is C here. Okay, let's keep going. This is really fun. I think we're now on to inequalities again. Yes. The sum of x and y is at least 2. So the sum of x and y, so x plus y, is at least 2. So it's greater than or equal to 2. But no more than 5. Interesting. So it's at least 2. So they want us to write it out like this, where we have on the left the 2, because it's greater than or equal to 2. And let me erase that. On the right is 5. So it's somewhere in between or including 2 and 5. That's how to write out that statement. You can do it all in one go rather than having two separate inequalities. X plus y is greater than or equal to 2, or 2 is less than or equal to x plus y, which is less than or equal to 5. It's a nice way of writing it. If the total of twice x and 3 times y, so the total of twice x, that's 2x, and 3 times y, is non-negative, meaning it's greater than or equal to 0. Because non-negative can include 0. So it's greater than or equal to 0. And no more than 40. Oh, it's that same thing again. Okay, they want me to write it in a line. It's between 0 and 40. So let's do that again with 0 on the left and 40 on the right. Whenever it's between two things, you write it like that with sort of a less than sign on the left and a less than sign on the right in between the two numbers. Okay, what's the question? Which of the following expresses all possible values of y? Well, I've got a 3y on the right here. So if I double this one, if I double this inequality, I would get 4 is less than 2x plus 2y. And then I've just got a y left out, haven't I? Which is 10. So notice I've got 2x plus 2y, but this is 2x plus 3y. How does that help? Write that a bit more clearly. So I know it might be quite hard to see on the screen, but I think that tells me that, look at the difference. We've got 2x plus 2y, but here on the right we have 2x plus 3y. And the 10 has jumped to a 40. So adding the y could add on 30, which is why I think the answer might be B. But let me think about the beginning. So I know the correct answer must be B because I know that the max value of y must be 30. But I'm not quite sure how they got the minus 10. So obviously in the real exam, I would just pick B and move on. But maybe someone in the comments can work out the lower end of y and show why it's minus 10. But for now, I know the upper end of y must be 30 because 2x plus 2y must be less than 10, but 2x plus 3y must be less than 40. So y on its own must be less than 30. So the max value is 30. So it's answer B, but maybe someone in the comments can finish that off and work out the lower end of the value of y. Either way, in the test, you've got the answer, so you would move on. Okay, this one. These are definitely higher level questions. I can tell they're not that easy. So 1 over x plus 1 over y equals 6, and then we've got that craziness. And we need to work out either z or x. Okay, first thing I would do in that second equation is just get rid of all the minuses because they cancel out on both sides and get rid of that fraction, that 3 on the left. So I'm going to do this quickly, but basically I'm going to cancel out the minuses straight away and I'm going to times both sides by 3. So we get 1 equals 6 and then that bracket of zy over z plus y. And that looks a lot easier to me. And now on the top, I'm going to add those two fractions together. The 1 plus x plus 1 over y equals 6. I'm going to cross multiply, add them up. And you get y plus x over xy equals 6. And now I would notice they look so similar. They look so similar. How can we... Maybe if we've got a 6 here on the left for this equation, but then we've got like a 1 over 6. So if we divide both sides here, we get a 1 over 6 equals zy over z plus y. So we could flip it. We could flip equation 1, and then it will look exactly like equation 2. I don't know if you knew that, but you can flip equations. So you have xy over x plus y, same thing as y plus x, equals 1 over 6. Because if you flip 6, you get 1 over 6. And on the right, 1 over 6 equals zy plus z plus y over z plus y. So the z and the x are the same thing. It's the same equation twice, just one with an x, one with a z. That was tricky. So both quantities are equal. I only got that by applying some basic rules of simplification. You look at an equation, you simplify it as much as you can. And after I'd simplified it, I noticed that the two equations looked stunningly similar. So I just flipped one of them and then I realized they are the same equation. Whew, these are a workout. Okay, next one. And then I can see we've got an inequality afterwards. Two inequalities afterwards. Question 10. A, B, and C are integers such that that, and then that, and then that. Three different equations. What is the value of A, B, C? What is the value of A, B, C? What's the quickest way of solving that? How would you... I mean, you could add them. What is the quickest way of actually solving that? Obviously, you could pick numbers, but no. We could isolate the C, sub it in here, then isolate the B and sub it in. Think about that. I actually genuinely don't know how to do that. Like, how are we going to get A, B, C? Like, we could times it all by C here to get A, B, C plus C squared equals 7C, but that doesn't help. The only thing I can think is just picking numbers. Because we know they have to add up to 6. And we know they're integers. And we know they're non-negative, right? Because none of these answers are negative. Although they could all three be negative. No, that wouldn't work. One of them could be negative. No, sorry, two of them could be negative and then one positive. What about just the numbers 1, 2, and 3 though? If it's 1, 2, and 3, that does add up to 6. This is probably not the best way of doing it, but I just honestly can't think of any other way. And then that does equal 5, right? Because 1 times 3 plus 2 is 5. And then 1 times 2 plus 3 is not 7. 2, 3, and 1. 2, 3, and 1. That's where you'd get 7. And then you'd get 5. And then, yeah, 2, 3, and 1. And so they multiply to get 6. That's kind of a random question, though. I only got it through picking numbers. Honestly, you can leave a comment if you know of a really fancy way of doing it. But in the real test, you do have to rely on picking numbers quite a lot. So I'm not embarrassed about that. Obviously, in terms of timing, you can see that I'm taking quite a long time, partly because I'm explaining it and partly because all of these questions are at the hard level. In the real test, obviously, there'd be more of a mix. But we get on to, I can see, 2 inequality questions here. So let's keep on going. A is between -4 and 9 inclusive, and B is between -3 and 2 inclusive. What is the greatest possible value of A minus B? To find the greatest possible value of A minus B, you want A to be as big as possible, as positive as possible, and you want B to be as negative as possible. Why is that? Because you're taking away a negative. And if you take away a massive negative, the 2 minuses cancel and you get a plus. So you might want to pause and think about this, but that's how it would work. If you want to maximize A minus B, you want to maximize A, but then you want B to be as minus as possible, because then the 2 minuses will cancel and you get a plus, which makes the overall answer even bigger. Okay, max value of A is 9, I can see here. The most negative value of B is -3, and 9 minus -3 is 12. So I believe that would be the greatest possible value. Next one. M minus n is greater than 3. Which of the following must be true? In other words, one way to think about this is the difference between m and n is 3. It's greater than 3. M take away n is another way of saying the difference between m and n. So the question's saying the difference between those two numbers is at least 3, more than 3. Which of the following must be true? Well, just because the difference is more than 3 doesn't mean they're integers. So those first two are out. M is greater than n. Yes, because if the difference is 3 or more, then m is bigger than n by 3 or more. So m is definitely bigger than n. So that's true. We know it's true by more than 3. If n was bigger than m, then when you took them away, you get a negative answer, not 3 or more. So that's true. Now, just because the difference between the numbers is 3 or more than 3, then does it mean that they're both positive? No, I don't think this is true. I don't think if you add them up, you get a positive answer, because the two numbers could be, I don't know, -2 and -10. And then the difference is more than 3. But that doesn't mean the two numbers, when you add them, is positive, so no. M minus n is greater than 0. The thing is, the question told us that m minus n is greater than 3. So if the difference between the numbers is greater than 3, well then yes, of course, the difference between the numbers is greater than 0. Because they've already told us that m minus n, the difference between the numbers, is more than 3. So m minus n, the difference is definitely more than 0. So that's also a tick. Does it mean if you multiply them, it's positive? No. If the difference between the numbers is 3 or more than 3, then it could be, for example, 1 and -4. That has a difference of more than 3, but one's positive, one's negative. So if you multiplied them, it would be a negative. So that's out. Let's cross these out. Lastly, if you divide them, that's a divide symbol. If you divide them, is it greater than 0? Again, no, because one could be positive and one could be negative. And if you divide that, it would be negative. So I believe it's just these two. And it all came down to me realizing, even without picking numbers, that when they say m minus n is greater than 3, I know that might look like a tricky inequality, but they're actually just saying the difference between the two numbers is more than 3. That's all they're saying. That's all you know about the two numbers, just that the difference between them is more than 3. So that helped me to think about it. Okay, let's move on. All of the students in a certain class are either 7 or 8 years old. 80% of the students are boys. Okay, let's stop there and start picking some numbers. Let's say that we've got 100 students, because otherwise this might get quite confusing here. So we've got 100 students, 80% of them are boys. So that's 80 boys and 20 girls. Okay, just immediately start picking numbers to work out what's going on. 25% of the girls are 8 years old. So 25% are 8 years old. 25% of 20 is, what is that? 5. So 5 of them are 8, and that leaves 15 of them that are 7, because it says you're either 8 or 7. Okay, you definitely in the test want to have better handwriting than me, but hopefully you can still read what's going on. So let's move on. Notice I've worked this out before even finishing reading the question. If there are an equal number of 7-year-olds and 8-year-olds in the class, there's an equal number of 7-year-olds and 8-year-olds. So at the moment, we have 10 more 7-year-olds because we know there's 15 7-year-old girls and there's 5 8-year-old girls. So we need to balance that out with the boys. So we need 10 more 8-year-olds among the boys compared to 7-year-olds to balance it out. So what would that be? Not 50 and 30, that's 20 more 8-year-olds. 45 and 35? Yes, if there's 45 8-year-olds and 35 7-year-olds, we've rebalanced it, because that was an extra 10 8-year-olds compared to 7-year-olds, which balances it out to make sure. Actually, there would be an easier way of saying it. You guys are probably saying there's a much easier way to think about it, which is if there's an equal number of 7-year-olds and 8-year-olds, that means there's 50 7-year-olds and 50 8-year-olds. This is a much better way of explaining it. And if there's 50 8-year-olds and we've already got 5 8-year-olds that are girls, there must be 45 8-year-olds that are boys. Anyway, I kind of explained it the hard way, but that's the answer. What percent of the students in the class are boys who are 7 years old? 35%. So it's 35 out of 100. Definitely illustrates the benefit of picking numbers there, by the way. No need for equations, by the way, so I'm not sure why this is an equations question. But we do have another inequalities question here, which is what I think most of you are after. So let's do this. If x is between -12 and -2, and y is between 3 and 6, which of the following could equal xy? Well, the most negative answer would be like if x is -12 and y was 6. You pick the most negative with the most positive. -12 times 6 is -72. So it's got to be at least -72 or higher. And now for the most positive. The most positive would be if x is -2 and y was 3. So basically the other pair, -2 and 3, would be -6. Now, if y was a negative, then we could have picked that to cancel out the negatives, but y can't be negative. So basically, x times y has to be between the lowest extreme, which is -12 times 6, and the highest extreme, -2 times 3, which is -6. So it's between those two, which means it could be -36 is in that range, and this is in that range, and this is in that range, but these last four are not in that range. So I believe that's the answer, those first three. It didn't say anything about integers, so it can be -14.5. Yes, I'm happy with that answer. Okay, last question. If x to the power of -2 equals -1.96. Okay, so this looks really complicated, but it really isn't that bad. X to the -2 just means 1 over x squared. And you see how it says -2 equals -1.96? A really cheeky, quick way to simplify that is just add 2 to both sides. So you get 1 over x squared equals, you could do this on the calculator if you want, but if you do -1.96 plus 2, you get positive 0.04. Now, I'm going to multiply both sides by 100 immediately because I don't like decimals. You guys know me by now. I really don't like decimals. So when you multiply the left, only the numerator gets multiplied. And if you multiply the right by 100, you get 4. Cross multiplying, we get 100 equals 4x squared. Divide by 4, so 25 equals x squared. So x is either 5 or -5. Okay, now let's solve the other one. Y to the power of a third. I've done an exponent video for you to check out if you don't know what to do, but y to the power of a third means the cube root of y. -5 equals -2. Add 5 to both sides, of course, and we get the cube root of y equals 3. And how do we get rid of cube root? We cube. So y equals the cube of 3, which is 27. Okay, so y is 27 and x is 5 or -5. But they've told us here that x must be a positive, because either they're both positive, so it's greater than 0, or they're both negative, so it's greater than 0. But we know y is positive, so x must be positive, so therefore x must be 5. And then x times y would be 5 times 27, which I can do in my head, that's 135. And we are done with that drill. I will of course quickly check my answers and tell you if I got any wrong. And I checked them, and fortunately I did get them all right. So if you like this format of video, where it's an intense drill set of practicing all the concepts that come up in my videos relating to equations and inequalities, obviously there are more drill sets, so I can do even more. But first I'm going to see if you guys feel it's helpful for me to go through these drill sets at speed. Please do let me know in the comments, and have a great day.